Okay, good afternoon. My name is Stefan Dreher from Ertico ITS Europe. I will have the pleasure of moderating this session on connected automated driving today. Before we start, just like to explain how this session will work. So we will start with an introduction by Tom Alkim from DG Research, the European Commission. After that, we will have 4 recorded presentations, which will be followed at the end by a question and answer session. So for the questions, so you will be able to ask questions during the presentations already using the conversation box on your left. But of course, we will address them without the questions only at the end of the last presentations. The presentation will be about 10 minutes. So that being said, I think we can start with the introduction by Tom Alkim, if you are there.
Yes, I'm here, and I hope that you can hear me. Good afternoon, everyone. I was asked to set the scene for this session, the first session of this 2-day event on connected and automated driving. We are promised a lot of nice societal benefits of connected and automated driving, but that can only happen if it is done right. And in addition to that, a variety of challenges need to be addressed before they can materialize. And to make it even more complex, this will only happen if all these challenges are met. So in that sense, it's a little bit comparable to a recipe. You need all the ingredients there. In general, you can categorize a lot of these challenges in different domains. And roughly, you could say there are 4 domains. There's one domain on the enabling technology. This makes it happen. Without it, you cannot have connected and automated driving. But if you have this, you also need an app legal framework to allow it on the roads. And it should also not be a standalone solution or service. It needs to be well integrated into the current mobility ecosystem. And if you have those 3 elements in place, then you still need it to be embraced by society, or in other words, if there is no trust and no users, you will have no benefits. So, needless to say, it is not that simple, and it cannot be done by one party alone. So, cooperation and a multidisciplinary approach is really needed in the field of CCAM. CCAM is the term that we use for connected, cooperative, and automated mobility. And in the upcoming framework, Horizon Europe, which starts in a few months, this is also demonstrated by a public-private partnership that is being prepared, the so-called CCAM partnership. And in this partnership, 7 different clusters are installed to address all of the aforementioned challenges and more. There are quite a lot of aspects. In this session, you will learn about important achievements and significant challenges still to be faced on 4 different perspectives for connected and automated driving. There is the ADAS and Me project, which is looking at the safe and swift transition of control between the driver and the software, so to speak. So this is very much linked to enabling technology. The other project is Head Start, which is looking at developing testing and safety validation methodologies. And this also helps in achieving a legal framework where you can assess this. Then the Levitate project looks at the assessment of societal impacts of connected and automated vehicles. This is very much linked to the societal embracement of these services. And finally, the C-Mobile project looks at connectivity and CITS, So in that sense, it's a little bit further than automated vehicles. CITS deployment is already happening. But we strongly believe that connectivity will help enhance the performance of automated mobility. And it is also, in a sense, linked to the integration in the ecosystem of mobility that we have nowadays. So I'm really looking forward to learn about all the progress and the achievements and remaining challenges of these 4 projects. And I hope that you all have an interesting evening. Stefan, back to you.
Thank you, Tom, for this introduction and for also quickly introducing the scope and the projects. So with that, I think we can go directly to the first presentation from about the ADAS and Me project by Anna Anund from VTI in Sweden. Okay, so this was the last presentation. I would like to thank all the presenters for the very interesting overviews of the projects. I would now like to invite the presenters to join the Q&A session and turn on their cameras. And to the audience, so as I mentioned, you can use the conversation box on the left. I mean, if you don't see it, you can click on the 3 dots. And you will see a conversation icon there where you can add questions. I do not see any questions so far. I don't know, do we have all the speakers? Yes. Okay, so then while questions hopefully come in, I can start maybe asking a few questions to some of you. I had a question for Anna on the ADAS and Me project. So you have studied also the distraction of the drivers, but I was wondering if you have also investigated the ways to keep the driver engaged, and in particular to avoid his complacency. And I know this is a very tricky subject when you are assessing the vehicles today and the existing ADAS systems by consumer testings, for example. And I know that there are different options that are being discussed, so I was wondering if your project found also some information out about that.
Thank you for the question. ADAS&Me was mostly focused on the transition between the driver and the human, and not to, I mean, of course, with help of feedback and warning, bring the driver back into the loop. But when it comes to, for example, sleepiness that was highlighted here, there are no really good alternatives to keep the driver alert for a longer time. The need is really that the driver stop and take a nap or keep on driving. So when it comes to sleepiness, no. So we didn't look into how to maintain an alert driver. It was more to detect and to make sure that the transition was safe between the driver and the system.
Okay, thank you indeed. And then I had maybe a question for Alvaro. So you mentioned now the main effort of harmonizing and defining harmonious methodology. So what was your main challenge or your main challenges, let's say, to define this harmonization for validation as
well, there are several challenges when we're speaking about harmonization on the validation methodologies. First of all, is that, as we already said, there are a lot of initiatives going on worldwide from the public and private sector. So it's important that we work on what would be the basic building blocks that would be common for all these methodologies. I think we're in a good direction when we're speaking about these building blocks, but there's still efforts that need to be done in this area. Especially when we're speaking about the scenario-based validation, if not very similar, you could see that you have the framework of these building blocks behind. There are other challenges that are also related to standards or standardization efforts. Let's call them like that, standardization efforts. And there are a lot of initiatives going on now, for example, in different standardization bodies like ISO and so on how do you define operational design domain in a way that is common for everyone. There are different initiatives, for example, on what would be the ontologies behind the databases that should feed this automated vehicle, connected automated driving validation methodologies. And this is important also when we're speaking about the databases. At the end of the day, what we want to do is to automatize as much as possible the testing of connected and automated driving functions. So it's important that we have good databases that are complete, that are reachable, that are easy to have interfaces with them directly or through middlewares, whatever you want to call it. And this is one of the big challenges we have. But all these things can be solvable. Okay? The most important thing is that when we're speaking about something that's relatively new but very promising, like a scenario-based validation, is that we all have the same direction, the same alignment when we are working on the methodologies and the procedures. You can then have some flavors, but the core must be in place there.
Okay, and thank you, Alvaro. And would you say that the methodology is now ready for new regulations?
Well, when we're speaking about regulations, this is a good point because regulations, for example, in Working Paper 29, there's a new regulation proposal, Regulation 157, which is the first one that is tackling directly what would be an automated driving function, level 3 automated lane keeping systems. So this is highly related, for example, with traffic jam chauffeur, which is one of the Head Start use cases. They have this 3-pillar approach in which they are using simulation, proving ground testing, and also field tests. All these 3 are covered in the Head Start methodology, but then you need to dive into the details. But it's a good example, this Regulation 157 for ALKS, because it's the one that it's first putting on paper what would be a new regulation on this. So the question, maybe I can re-question you. it's more. We have now a regulation which we did not have in the past. And scenario-based validation methodologies can work with this regulation. So we can have this legacy retrocompatibility. This is something that we are also working with in the Head Start project, how this can be achieved.
Okay, thanks. I see now another question for Alvaro coming in for Head Start. So you mentioned the use of V2X as a sensor. Can you please explore on how you intend to ensure credibility and applicability of such received information? Hello. Alvaro, did you hear the question? Alvaro seems frozen. Yeah. I don't know what happened. Okay, then maybe while Alvaro is unfreezing, maybe I can ask a question to Andrew. I don't know if Andrew, you're... Yeah. Okay, you're moving. Great. It's very small. So Andrew was wondering about the policy support tool, because you presented there that it's supporting several use cases and so on. But what are the future plans? So is there a way to then, because I guess this policy support tool is also meant to be constantly updated, maybe in the future, to allow for new use cases to be added? Are there some plans also to look into other use cases, maybe towards more operational aspects?
Well, that's the plan. I mean, the main thing is to get the policy support tool constructed. And that's going to take some time and will be available towards the end of the project. After that, it's really anybody's guess where we go with that. We would like to see it continued because we see that it will have a value in terms of policy formulation and policy development. And of course, as you rightly say, there are use cases that will emerge as automation becomes more prevalent. So we really need to have some sort of mechanism to be able to allow that to happen in the future. I guess that's a little bit out of our hands. We can only predict so far into the future. And at the moment, our future is within the next 4 or 5 years. what happens after that and how the policy tool can be handled to cope with that is a little bit unknown.
Mm-hmm. And have you also, because I've seen you have used some simulations and some tools to analyze, but have you also looked at a project? I mean, for example, we heard from Alex for C-Mobile that they have been collecting those information there about the Glossar application. Have you been looking as well at real assessments done already by previous projects or ongoing projects?
Oh, that is part of it. Yes, we're certainly not ignoring all the evidence that's already out there. We're not starting from scratch here. So there has been substantial reviews of what is in existence, and we have learned a lot from previous projects. So that will be part of the policy support tool to really capture that information that exists from projects such as SafetyCube and other safety-related and mobility projects, so that the policy support tool can bring all of those under one umbrella.
Okay, thanks. I've seen that Adao is back in the meantime, but Adao, can you hear us?
Yes, I can hear you, but I could hear you the whole time, but I don't know if you could hear me. I just turn off my video if it makes better. Can you hear me now?
Yeah, we can hear you. We cannot see you, but we can hear you at least. That's most important. There was one question for you actually related to V2X as a sensor.
Yes, I heard it and I've been answering it for a while, but you couldn't hear me at all.
You have to repeat yourself, sorry.
Yes, connectivity. No, we're speaking about connectivity. Yeah, the V2X, it's considered, as we said, one of the key new technologies. What we wanted to do here is that we consider that connectivity and V2X, it's an important part on the automated driving function itself. So we had to make some decision on how to include it in the methodology, and one of them was to include it as another sensor, a sensor that is able to inform the vehicle about things that may happen in the next hundreds of meters or even beyond, a little bit of what's being done in C-Mobile, for example. And one of the things that we have been working, and it's work in progress in that direction, is how do we include V2X in the whole validation methodology, but taking into account that, for example, we are making use of different standards like OpenScenario, which somewhat tackle connectivity, but not completely. It's important for us, and we've been working in this direction. In the OpenScenario, you have different layers. If the information in these different layers, it's enough, or if we need to add something. And in fact, one of the use cases that we have chosen in Headstar, which is track platooning, it's very important for us because if you think about track platooning or platooning in general, at the end of the day, the ego vehicle that is under test, the automated driving function that is under test, it's going to react differently depending on the messages that are being sent by other vehicles that are surrounding this automated driving function. Say it another way, the automated driving function will react or will do things differently depending on the messages that are coming from the trucks that are surrounding, in front, behind. And this can be extended in the future to other complex interactions in which you have other vehicles that are CITS enabled and sending information on what they're doing. Or next step is, for example, intention. I'm going to change into this line, be careful. The automated driving function needs to know this. And that's how we are trying to introduce V2X within the Headstar methodology. It's an initial step. There's a lot of things that need to be done in that direction. But what we wanted to set up is the basis of what is needed, what is required, so connectivity and especially V2X is not an alien thing to the whole methodology. This opens the door for future developments and especially not forgetting about connectivity in future, for example, databases, which you need also to consider parameters associated to V2X within the field operational tests or pilots or whatever. I don't know if I answered completely because things are going on, but main message is that we have been working on how do we include V2X as a sensor, but as an element that is affecting the automated driving function under test.
Okay, thank you, Alvaro. Yeah, and I think you have probably processed the same way with the other key enabling technologies cybersecurity and so on, which are not that taken into account in validation. See, there's another question now which actually can apply to all of you. So it's how automated vehicles will avoid traffic jams and accidents in an urban environment. I don't know. I think maybe all of you can a bit reply to that. Should we start maybe with Andrew?
If I take the example of accidents first, I think eventually when the whole fleet becomes automated, then the chances of us reducing accidents to a minimum are very high. I think the tricky thing is, in the interim, we'll probably have mixed fleets of vehicles. So some will be automated, some won't be automated. Data from the US suggests that particularly the automated vehicles are at high risk of being hit by other vehicles. So the automated vehicles obey the traffic rules to the letter, whereas the non-automated vehicles tend to take more risks. And that's when the problems tend to occur, when you have this mixture of automation versus non-automation, simply because of the different obeying of the traffic laws. So if you just imagine coming to a red signal, for example, or where the light's about to change, sometimes human drivers will take the risk and go through the traffic lights. The automated vehicle will always stop at that traffic signal. And when it does that, and the vehicle behind is anticipating that the vehicle will pass through the signal and take the risk, and that's when the problems start to occur. So this difference in obeying traffic laws which generates problems. In terms of congestion, we are looking at that in Levitate. Indications are that I think automation will solve some of the problems, but not all of them. And the real solution has to rely on adequate navigation and rerouting, so that when congestion is predicted to occur in urban areas, that there is adequate rerouting of vehicles to less congested routes.
Okay, thanks, Andrew. So Alex, did you have also similar conclusions from your data or analysis so far, or is it when your other insights? I think you're on mute. No. No, we still cannot hear you. That's the camera.
I think it works now.
Can I maybe say something while waiting?
Just one.
Yeah, okay.
Please go on. I wanted to ask you.
I take the floor. Okay. So I would like to say that we can look at it from the other perspective. I mean, learn from Aras and me, we can see that, for example, automated docking functionalities at bus stops will decrease the stress levels in the drivers and also, I mean, improve the safety for the passengers with the less hard brakings or hard accelerations. So there is also a way of improving the things. And just by the fact that you can also add information about the driver's state to the automation will be some sort of guarantee that you will not, I mean, let the automated vehicles go by themselves without having this information about the possibility to check back or hand over the control, as long as at least the drivers are still in the loop. So I think that at this point, when you still need to have the driver on board, you need to connect those two, the driver and the vehicle, in a clever way, and then you will improve the safety, not decrease.
Yeah, maybe we can hear you. Can you hear me now?
Yes, perfect. Thank you, Alex.
Yeah, okay. Sorry, I don't know what was happening. My mic wasn't turning on. I fully agree with both argumentations. I will probably make another one, which is quite interesting to me as well. So, and it's about route planning. So not just this avoidance of traffic jams and accidents that are immediately there, but how to deal with decision-making strategies and planning strategies to directly avoid those traffic jams, let's say, previous to find them, right? So I think CITS could play a big role as well. So it's a little bit the conversation that we were having with Alvaro about V2X as another sensor. So if we can probably have in an automated vehicle extra information, beyond the vehicle, the current vehicle sensors and its surroundings, and this would come through CITS and V2X communications, then we can have extra information and we can anticipate to our future, right? In an horizon that electronic horizon that we don't see really, because our sensors cannot see it, but communications allow us to know it, or allow the system to know it. So it's not only about the immediate avoidance, but also about the preventive avoidance in terms of route planning as well, I guess. This to me would be another strategy.
Okay, we received another question now in the meantime, but I'm not sure to be able to understand it. Does somebody understand the abbreviations? PN will give you information which can be. Maybe a problem with the keyboard. I don't know. Okay. Okay, in the meantime, we have about 10 minutes left. I don't know if maybe Tom, do you have any questions for the speakers, or know that you have been working as well quite a lot on the transition of control before, or looking into these aspects?
Yeah, maybe I had a question for Anna on the others and me on the. It seems like you can be quite efficient with the HMI strategy if you take advantage of a personalized approach. But on the other hand, you also want to have harmonized solutions. So how do you find the balance between that?
Yeah, thank you for the question. I mean, in Aras and me, the starting point was a generic approach when it comes to the strategy itself with, feedback, warnings, but also now the intervention, where we use the automation as a part of the intervention also to really stop the car. But for the harmonization, that might be maybe then for the more like the type of modalities and the type of concept to make it easier for the drivers to understand when a system is, asking for your information or confirmation, or when the system is actually acting under automation. So things like that could be more harmonized based on the results we have. But of course, it needs to look differently. It's not the same thing to ride a bike on a long stretch compared to driving a bus in the city center. And in this case, we also need to be aware that for, bus applications, for example, there are also other people surrounding, and for sure not always the bus drivers have an interest to let everyone know that I was not able to, take over the control because I didn't look correctly in the mirrors, or I was detected to be too sleepy and things like that. So it's also this layer about acceptance in relation to other road users around. And I guess that this would be the case also for car drivers. So I'm sorry, it's not an easy question to answer, but there are like these generic principles that I think we can benefit from, but they need to be adjusted depending on the type of operation you're working on or in.
Yeah, thank you for that. Maybe this also links to the other question that we have in the chat box that says, apart from the results that you have presented, do you also have major research needs identified? I think this question is to all of you, but here specifically, you could also think about one of the other European projects that is quite similar, Mediator, for instance. Are there any results or questions, research questions that you could transfer to them or forthcoming projects in Horizon Europe?
I mean, from the RSME point of view, absolutely. We are also partner in the Mediator. But I think that the things that we started with in RSME about, I mean, fusion of different driver states, for example, is one of them that we need to know much more about. Now we work mostly on single detection systems and fuse them, but humans are very complex. So most often we are maybe both, fatigued and inattentive. That's one thing. Another thing is that we need to, for sure, adjust the sensors we use to detect changes in driver state. I mean, if you are under level 2 already, this is a study we did in Mediator actually, together with some other studies, but then you can see that the behavior of the driver starts to change. You look away and it's okay to look down for a short time and so on. And for example, then the camera systems, they are not built to detect things when you're not looking ahead. That's also why we said in the presentation that we would like to improve the distraction algorithms. I mean, what is really a relevant field of view? It's not just by looking ahead or like looking away for too long, because now you need to do other things that is correct. So this is something we need to bring with us. And the area that the cameras is like covering is also much more, I would say too limited to really keep track on what is happening, especially when it comes to professional situations with bus and truck drivers, because then you really need to be moving in a different way, and the cameras is not like, the system is not built for that. So that's also something we need to understand much more about. And of course the thing, what is happening when you are under automation already at level 2, we can see that this will of course contribute to the development of driver impairments in a different way. So, I mean, if you drive with an L2 system on during nighttime, we can prove that you will suffer more from sleepiness during nighttime, but not during daytime. So we also need to understand the complexity of the biological things to make this accurate. Just some small parts.
But maybe we could ask the same questions to the other speakers before we go to the other ones. So about for example, Alex, do you also have any comments on that? So do you have major research needs identified?
Yeah, definitely, yes. Despite CITS services have been implemented since many years now, we are now talking about large-scale deployments. So we are having new research questions and new new things to learn. So yeah, I would say many research questions. How to engage new conventional users, till how to partnership or collaborate with public-private stakeholders. How to get models out of these services useful for the cities and that really impact mobility the way we want. Yeah, many things to run still and to be answered. And hopefully we'll get some answers at the end of the project. But I guess this will go beyond the project in the next years.
There was because yes, you have been speaking. There's another question just for you as well. Are citizens interested in CITS services?
That's a very good question. I would say yes. So all the interviews that we run in C-Mobile and the first feedback that we are getting from users, it's always positive. The point is, we are just identifying a few or low percentages of people that are aware of CITS. So the the ones who know are interested. The ones who don't know yet, there's a previous step before doing that or before making that question, which is basically getting them to know. And this is a really big challenge for everybody at European level, I would say, in the next years, to get people to know, people of all kinds, not only people but cities in general and other stakeholders, to know actually about CITS and what CITS can bring to mobility and in the future to automated cars, right? So yeah, still a lot of work to do, but I'm positive, at least from this first result that we are getting and we are seeing in the project.
Okay, thank you. Yeah, it's very interesting indeed to use our awareness. It's at least one of the most important at the moment. Okay, we just have 1 minute left, so I know that there are still questions coming in. Maybe I would just like to finish the round with Andrew as well about the research needs that you have identified or challenges.
I think one of the challenges is the issue of transition to alternative fuels, especially the drive towards electric vehicles. The UK government has made some major announcements about the way that the fleet is going to change by the year 2030, with electric vehicles being a major constituent of the vehicle fleet. This has enormous impact on the city infrastructure, how it provides charging points, etc., how it will cope with the transition from traditional fuels to alternative fuels, how users will cope with these new changes. The technology is moving very, very quickly, but are the users or are all the users ready for this rapid change of progress? Those are two of the challenges that I can think of that immediately spring to mind.
Okay, thank you. Yeah, I don't know what will happen now in 10 seconds. We are about to finish. So maybe Alvaro, if you have just one quick thought.
If not, I will get freezed again. Very quickly, I already commented some of them. One of them is about what do we do with, for example, communications, P2X. This has already been explained, but it's associated to the issue with databases. We have different initiatives on databases. Some of them are public, some of them are private. How do you interface with these scenario databases that should be part of an automated validation methodology as the one we are working? The other thing, it's more related to, everything is related, but the other thing is there is also some, let's say, a lack of maturity in some aspects on simulation or virtual testing, in which will depend on the scenarios that you have on this and the models that we're using, the quality of the models that we are using, and the models that you have from different parts of the vehicle. It's not just the automated driving function logic, but also sensors. And this also links to another challenge, which is something that was addressed by Edis and me, as well as other projects, which is human factors. Sometimes, currently, there is a trend to evaluate safety assurance of automated driving function depending on the average statistics for a human driver. Or if a human driver will not be able to do this, but an automated vehicle is safely doing this, then it's okay. But how do you include this within a validation methodology that will give you a threshold about what should be safe enough to go to the street? And this is also a challenge. Within Head Start, we included human factor as part of the input, but again, this is also out of the scope of Head Start itself, but it's also that something should be considered, especially when we're speaking about safety assurance in comparison to humans. And mostly this is the thing. We also have some other limitation in terms of white box testing, black box testing, but it's already, as we were saying, it's more about the models that you have and the quality of the models that you get.
Okay, thank you very much to all of you. I think we have to close because there is still the summary session outside. So thank you very much again for your participation, and to the speakers for the presentations and the answers to the questions. So I'd like to invite you all now to return to the lobby, so you can exit the session, and there you will have to attend either another session or visit the exhibition. Thank you very much for.
Thank you. Bye bye.
Thank you.
Thank you. Bye bye.
Thank you. Thank you.
Bye.